Hello, ladies and gentlemen. This is Dr. Robinson again, and we're going to continue our studies. This time we're talking about permutations. Permutation is an arrangement of objects in a particular order. So the order is going to be distinct, and it's going to be uh, definitely a certain way that we have to arrange it. So it's got to be particular and different. So factorial is the product of all positive integers less than or equal to the number. The symbol for factorial is this exclamation point. For example, 4 factorial, some people say 4 exclamation point, but we really say 4 factorial. That would equal to 4 times 3 times 2 times 1. And when we multiply, 4 times 3 is 12, 12 times 2 is 24, 24 times 1 is 24. So that's a way of multiplying using what's called factorial notation. We have the factorial button on our calculator, and we can use it by pressing the PRB, probability button, and you'll see it as soon as you press it. So let's get started. Find the number of permutations of the letters H, E, N, D, L, E, and E. So we have the word, it looks like handle, and we want to make arrangements out of it. So how many different arrangements can we make? Well, let's see. First thing I'm going to do, I'm going to count how many letters are there. 1, 2, 3, 4, 5, 6 letters. So I have 6 letters. So I'm going to draw 6 blank lines. And for the first letter, I have a choice of 6 different letters that could be here. I could put the H or the A or the N, D, L, E here, and there are 6 different letters that can be placed there. So I have also a second letter that has to be placed. So a second letter, if one is remaining, and it has to be different from the first, so I can't repeat, like have H here and H in the second one. So if I put the H here, so I'll make believe I'll put H here, which leaves me 5 different letters to put in this spot right here. So I have now 5 letters remaining to put there because they have to be different because I've already used the H. So suppose I use the A to be the second letter to represent. Now I'm left with my third letter now. So my third letter, I have a choice of using other letters other than H and A because they're holding these first 2 spots. So I got 4 different letters to choose from, and I can choose the N to hold that spot. So I'm going to keep going down. If you see the pattern in order, for the 5th spot, 6th spot, I'm going to have the D hold this spot because there are 3 letters left, and the L hold this spot for the 5th spot, and the E hold the last spot. And I have different letters each time in all 6 of those spots. So when you have different items occurring at the same time, if you remember our video on the counting principle, we have to multiply all of these different items. So our answer is going to be 6 times 5, which is 30. 30 times 4 is 120. 120 times 3 is 360. 360 times 2 is 720. And 720 times 1 is 720. So we can have 720 different permutations for this arrangement. It sounds like a lot for such a little word, but remember, H could be there for all of these different times when you arrange these 5 letters different times. And you remember you have other letters that have different chances of being in the first slot. Well, the H moves on down, and that's going to be quite a different amount of letters, and what a large tree diagram this would make. So the counting principle tells us, remember, to multiply the number of different items times the number of different items together when we're doing them, and that'll give us the total amount of different items together. So that's why it is 720. 6 times 5 times 4 times 3 times 2 times 1. So that's permutations. Here we have one for you. Omri plans to shop, call a friend, study, and exercise on a weekend day. How many arrangements of activities can he plan? So that's one you can try. So he has a few things he's doing there. I notice he's doing some shopping. So he's going to shop, call, study, and exercise. So it looks like he's doing 4 different things. So 4 different things. They want to know about those different things, which way we can arrange them. So see if you can arrange those 4 different things, which would be first, second, third, and fourth. So which could be the first activity? So he has a choice of how many things. Looks like he has a choice of 4 things. And then he has a choice of 3 things, because he'll do whatever, shop maybe first, or he could call, or he could study. So I'll just say, suppose he wants to shop, but he cannot shop if he's going to do something different on the second one. So if he's already shopping, he's got to do something different for the second activity. So his second activity has to be different from the first activity. So that leaves 3 activities that he could do. Maybe he could call, and that leaves 2 activities left because he's shopping and calling. So he could then maybe study, and the last activity he could do could be exercise. Now, it doesn't have to be in that order. This is just one possible order. And remember, you have 4 different things that he could do. He doesn't have to shop. He could call, or shop, or study, or exercise. So there are 4 different things that he could do first. Then it leaves 3 different things, and 2 different things, and 1 different thing. And if you remember, the counting principle says if you have all of these different things that you're doing at the same time, you multiply, multiply, multiply. 4 times 3 is 12. 12 times 2, 24. 24 times 1 will give you 24. So our answer would be 24. So Omri has 24 different things that he could be doing in his little plan there. And I even use the factorial symbol because I remember 4 factorial is 4 times 3 times 2 times 1. So check your understanding, see if you understand it so far. If you don't, watch the video, bring your questions in tomorrow, write them down. I'll be glad to answer them. Here's a question for you, and this time it's a little bit different. Josh is in a motorcycle race with 7 more cyclists. Suppose that there's a first, second, and third place winners are to be chosen. How many ways can you choose the winners to be chosen? So you have a first and second place and third place. So there's a first, second, and third place. And you have Josh in the race with 7 people. So that's a total of Josh plus 7 other people. So there are 8 people in the race. And you have first place, second, and third. Well, obviously somebody's not going to win, so there only could be one winner. And how many different people could win? Well, Josh can win, or any of the other people could win, so there are a total of 8 different people who can win. And if one person came in first, then that leaves 7 people to come in second. And if somebody came in first and somebody came in second, then that leaves 6 different people to come in third. And if you remember what we are supposed to do, when we have all of those different things that are choices that are coming together, the counting principle tells us that we multiply, multiply, multiply. 8 times 7 is 56, and 57 times 6, I believe, is 336. So there are 336 different ways that winners can be chosen. Well, what happened to those other people? Well, unfortunately, they did not place, so they don't get a trophy or anything. So we only have a first, second, and third place. So keep this in mind. You may not get a winner. Everybody may not get to be a winner. So there might be an exception where you have to choose from a certain set of numbers to fulfill a certain amount of spaces. We have a calculator button that deals with that. So we press our PRB button, and if we type in the first number, press PRB, and select NPR, the P stands for permutation, the N stands for the number of people that would be altogether in the total, how many number of objects there are. Whereas R is the people who are used, or the rate of usage that are actually participating in it. Like the example we had before, there were 3 places, so 8 people were in the race, but only 3 places were awarded. So that's what we mean by rate of usage. So if you press enter and type the next number, and press enter again, you would see that you'll get that answer. So that's good steps if you're going to use your calculator to do it. So here's an example that you can try on your own. So here's 6 seats for these people to sit in. See how many different ways you can have them arranged in a row. So try that one. That looks good. Check your understanding. If you understand it, great. If you don't, write down your questions. I'll be glad to answer them tomorrow. Here's another question about seats again. This time there are 4 seats. So we have fewer seats, and looks like we have a lot of people to sit in 4 seats. Sounds like somebody's going to be standing up. So I hope you got something out of this video. And remember, if you have questions, write them down. I'll be glad to answer them in the morning. This is Dr. Robinson, and I'll see you then. Bye-bye.